Yes, sir. Good afternoon, class. I welcome you to our new topic of today, gravitational force, weight, and mass. We are still connected through Metric Hub, and just connect and keep on turning on your notification button for continuous information and lessons that are going to be posted on our channel. So today we are going to talk about gravitational force, weight, and mass. Without wasting any time, I'm just going to quickly define these terms, and there will be some calculation that we are going to do at the end of the lesson or at the end of the class. The terminology, gravitational force, the field that pulls matter together, it's the field force. It is the field force that pulls matter together, gravitational force. It pulls matter together. It is a field force that pulls matter together. And then weight, the gravitational force that the earth exerts on object measured in newtons. I once said that newtons, we always use abbreviation of N to represent what? To represent newtons. So it is gravitational force that the earth exerts on an object. That is weight. The earth, the gravitational force, we are saying that it is the gravitational force that the earth exerts on an object that is measured in newtons. Are we together there? And mass, the amount of matter in an object, that is mass. Mass is the amount of matter in an object and is measured in kilograms. The SI units, in other textbooks or question papers, you'll see where they would say give the SI units for the following. They will say give the SI units of the following. So I'm saying in terms of weight, the SI unit is what? It's newtons. Weight is newtons, and then we are saying mass is kilograms. Mass is kgs. And then we are saying gravitational force is measured in what? Gravitational force, again, we said that it is measured in what? In newtons. So please take note that when we are looking into this, you must be able to understand the meaning or the definitions of each of these terminologies. SI unity is the same as I'm saying these are the unity of specific masses or specific weights that we need to understand. And then gravitational force is a field force that pulls mass together. The magnitude of gravitational force between two objects, the mass, it is field force that pulls mass, that pulls matter together. The magnitude or the extent to which the gravitational force works, the magnitude of the gravitational force between two objects depends on mass of the object. It depends on the mass of the object. The heavier the object is, the greater the gravitational force. The heavier the object, the greater the gravitational force. So gravitational force is affected by what? By weight. It is affected by mass. So it also increases as the object move closer to each other or move closer together. It also increases as objects move closer together. That's one other thing that we need to understand, class. All objects exert a gravitational force on objects around them. All objects exert gravitational force on objects around them. So the Earth exerts gravitational force on object on its we are saying the Earth exerts gravitational force. The Earth exerts gravitational force on the object on its surface. On the object on its surface, you also exert a small gravitational force on objects around you. As a person, we are saying as a person, we or you or me or any person, we exert gravitational force on objects that surround us. Let's look into weight and mass. The gravitational force that an object exerts on objects around it is called the weight. Gravitational force that an object exerts on objects around it is called weight, and is measured also in what? In newtons. Weight is measured in newtons. The mass is the amount of matter in the object and is measured in what? In kilograms. I'm sure that we also have just mentioned it. We just mentioned it just now. So what I'm saying is, please note that these things, you must not forget them. You mustn't forget these definitions. The mass of an object remains the same no matter where it is, because the amount of matter in the object does not change. Mass is constant. Mass of an object remains the same no matter where it is, because the amount of matter in the object does not change. We are saying whatever that makes an object does not change, hence the mass of an object remains the same. The weight of an object will change depending on the gravitational force exerted on it. Weight, classy, weight of an object will change depending on the gravitational force exerted on it. An astronaut weighs less on the moon compared to on the what? On the earth. So depending, we are saying an astronaut weighs less. An astronaut weighs less on the moon compared to on the earth, because the moon has a weaker gravitational force. Because the moon has got a weaker gravitational force. The Earth's gravitational force is what? Is 9.8 meters per square second. Meaning that a kg object has a weight of 9.8 newtons. 1 kg is the weight, has got a weight of 9.8 newtons. Let's just work on, we just want to do some calculations in order for us to understand these examples that we have just given here. The formula for calculating weight is equals to, weight is equals to mass times what? Times gravitational force. Weight, which is given as W, is equals to mass multiplied by gravitational force. Multiplied by gravitational force is what? Is what you call weight. So having this, I just attacked this triangle here as to help the class in understanding these formulas. In understanding these formulas, we can just give a simple formula, or this summation, which is given as to say W, which is weight, is equals to weight, and then we also have what? We have mass, and then we have got what? We have got gravitational force is equals to, and also gravitational force there. These two triangles or these two formulas are the same. So in other words, we can just say when we want to calculate weight, weight is calculated by multiplying m times what? M times g. This is what is happening here. Weight is calculated by multiplying m, and what? M multiplied by g is equals to what? Is equals to w, which is given there. So if you want to calculate, this formula can be used to calculate either of these three. We can use the formula to calculate weight. We can use the formula to calculate gravitational force. We can use the formula to calculate mass. So in this case, class, check here. If you want to calculate mass, mass can also be calculated. We can also maybe say that if you want to calculate mass, we just close it. If you want to calculate mass, we can just cover the formula that we want to calculate. For in this case, if you want to calculate mass here, if you are going to calculate mass, let's just say we cover this one. We cover this. If we cover this, therefore it means when we are going to calculate mass, mass is equals to W over G. W over G can give us what is gonna give us W. Gonna give us M. W over G. W over G can give us what? Can give us M. As you can see there, we have just covered M. M is blocked here. Therefore, in order for us to get it, it means we have got W over G. That is how this can be used. And again, if you want to get G, this is also called subject of formula. This is also called subject of formula. How do we get G? G, we can also get G by, this G, we can also just maybe say that we cover G here. G is equals to W over what? Over M, which we can just calculate here to say that we have got, we got these formulas there. We can therefore just quickly say that we have got W over G is equals to M. So we want to make G subject of the formula. You want to make G subject of the formula. If you want to make G subject of the formula, we can what? We can multiply by G both sides. We multiply by G here. If we multiply by G there, and then we multiply also by G this side, and then we are going to get G. W is equals to what? We are going to get W, this G, and this G can cancel each other. Therefore, we are going to have W is equals to mg. Is equals to mg. So we want to get G, we divide by M both sides. We divide by M both sides. So we are going to have, which is going to give us G is equals to W over M. G is equals to W over M. So class, understand that if ever you are going to calculate any formula or make any calculations where you are given one formula, it can be possible to calculate all the variables that are given, that are appearing on the formula, by making the one that you want to do a subject of formula. That's what we are doing. So without wasting any time, I just want us to work. I just want us to calculate the questions that are given below here. I just want us to calculate the questions that are given. Here. Let's just quickly answer those questions. Let's just quickly answer the question. Example: calculate the weight of a 2 kg object on Earth. Calculate the weight of a 2 kg object on the earth. So weight, as we have said, weight is equals to m. Weight is equals to, this is equals to mg. W is equals to mg, is equals to, this is equals to mg. W equals to mg in this case, and then mg is equals to our m, our mass is 2. This is our mass multiplied by what? Multiplied by our g, which is given that it is 9 point what? It is given as 9.8 there. This is g, this is g there, this is g given there. So m, our m is 2 kg, and our g is what? Is 9.8, which is going to be given as to say w is equals to 9.8 times 2, we get 16 point what? 16, I mean 19.6. 19.6. This is what is happening in this regard, or that is what exactly is happening in that question. Calculate the weight of a 2 kg object on Earth. So it is given that our gravitational force is 9 point what? 9.2, 9.8 k, 9.8 newtons, and then multiply by what? By 2, and then we get our weight as what? As 19 point what? 19.6 newtons. Name two factors that affect the gravitational force between two objects. Gravitational force is affected by the mass of the object, and the distance between the two objects. These are the two factors that affect the gravitational force between two objects. Two factors that affect the gravitational force between two objects. It is the mass of the object and the distance between them. We have got the next question. An astronaut is a mass of 100 kgs. Calculate the weight on Earth and the weight on Earth, and on Moon, which has a gravitational force of what? This is the weight of the what? This is the gravitational force of the what? Of the Moon. So calculate the weight on Earth. This is weight on Earth is equal to W. W is equal to mg. W is equal to mg, which is m times g is mg class, is the same thing as mg. W is equal to mg. So when we do that, our weight, our W is therefore given as to say we have got 100 kgs on Earth. On Earth is 100 kgs multiplied by 9.8, which we have given up there, which would give us 980 newtons. 980 newtons. I'm sure you can see that. Our 100 kgs is given here, and then our 9.8, our 9.8 gravitational force is also given in question above. And then the weight on Moon, is equals to mg. W is equals to m times g, which we are saying our kgs are the same. Our mass does not change. Our mass does not change. Remember, we said mass does not change. So we are saying our mass is equals to 100 kgs multiplied by what? By 1,6, which is on the Moon. 1,6 or 1,6 is on the Moon. Hence we get what? We get the weight is what? Is 160 newtons. We get as 160 newtons, which is given there. So before we go anywhere, the factors that affect gravitational force between two objects, the mass of the objects and the what? And the distance between them, and then calculating the weight on Earth and the weight on the moon. You can see that on Earth we have got 980 newtons, and then on the moon it is what? It is 160 newtons, as we have calculated there. Calculate the mass of a block on Earth that is a weight of what? That is got a weight of 980 newtons. So in this case, our weight, we are saying weight is equal to mass times gravity, mass times gravitational force. So our weight, we are given that weight is equal to 490 newtons there. And then we are saying 490 is equal to m times what? Times the gravitational force that is given there. So m is equal to, class, take note here. I'm saying don't make mistakes of this question. Don't make mistakes of this question, because what you are asked to calculate, don't forget that you are calculating what? You are calculating m. So m, you, like I said, let me just easily maybe let me start by rephrasing it. Weight is equals to mg, and then we are given our weight. Our weight is equals to what? Our weight is equals to 490, is given as 490, which is equals to m. That is what we want to calculate. M multiplied by what? By gravitational force, which is what? 9.8. 9.8 there. So what we want is to get m. So we divide by what? This is equals to 490. 490 is equals to 9.8 m, and then get m, we divide by what? Divide by 9.8, divide by what? By 9.8, both sides. So when you divide by 9.8 both sides, you are going to see that 490 over 9.8 is equals to 50 kgs, which is equals to our mass, which is our what? Our m. So please, class, don't make mistakes. I'm just trying to simplify further and try to make it more clearer than whatsoever. So these questions, they do appear, and please don't make any mistake, because such mistake will cost you. Thank you very much for listening and tuning on. Just look forward to the next presentations, and thank you so much.